So now we see noise and the modeling of noise sources. So before that, we see what are the different sources of noise. Then we model the source of the noise. So later we concentrate on the measure of noisiness of an amplifier. That is, we measure the noise figure of an amplifier. Then we concentrate on the measurement of RMS value of output noise voltage of a network. Then we see the equivalent bandwidth and noise equivalent temperature. Then we consider average noise figure of the amplifier, the average noise figure of the cascaded amplifier, or so multi-stage amplifier. So noise is unwanted disturbance or is unwanted signal. So most of the signals that exist contain some amount of noise inherently. So here, as the main constraint of all the communication systems is the noise, because the purpose of the communication system is to transfer the information from one place to another place. So during the course of transmission from one place to another place, definitely the information bearing signal may be contaminated with noise. So noise characterization is very important, and as the noise is the random signal, so we use the statistical measures or statistical techniques or probabilistic methods to analyze the communication system in the presence of noise. So basically there are two different type of noise sources. One is the man-made noise source, and another one is non-man-made noise. So the name itself indicates a man-made noise is the noise that is generated by the appliances that we use, okay, or due to the contact of the electric contacts, or due to the electric ignition and all those things. I think you might have observed some type of noise in the television when somebody is grinding or mixing something in the kitchen. So that is due to the electric switching of the motor or some appliance. So such type of noise is called as the man-made noise. This man-made noise can be eliminated. Why? Because we can keep the source of the noise away from the system under consideration. For example, the system of our interest is the communication system. So we can keep the noise source away from the communication system, or otherwise we can keep the communication system away from the source of the noise. So there is a chance of eliminating the noise, or we can keep the source of the noise away from the system under consideration. So by that way we can reduce or we can eliminate the man-made noise. But if you consider the non-man-made noise, so there are two different types. One is erratic natural disturbances, whereas these two noises occur natural. So therefore, we cannot keep the source of the noise away from the system, or we cannot eliminate the noise completely, but we can reduce the noise by proper design of the system. That is the difference between the man-made noise and the non-man-made noise. Another noise is the fluctuation noise. So these two comes under non-man-made noise. So here this erratic natural disturbance due to intergalactic disturbances or some radiations in the solar system. So such type of disturbances takes place, and that is called as the non-man-made noise, and that is the erratic natural disturbance. So we already know that in the solar system there may be radiations, electromagnetic radiation. So these radiations always disturb the signals that we are transmitting, the information bearing signals that we are transmitting. So here we cannot keep the source of the noise away from the system, because throughout the universe the effect of these disturbances will be there. So we cannot keep the communication system away from the source, or we cannot keep the source away from the system. So that's why this type of noise cannot be eliminated. Hello? So this is the natural disturbance, or erratic natural disturbance. This noise is the non-man-made noise, or this is the natural noise. The source of such noise is natural. Therefore, we cannot keep away from the system under consideration. But this particular fluctuation noise is internal to a particular system. So this is also called as the internal noise. So it is internal. See, this is external. Erratic natural disturbance is external to the system. But in the system itself, we consider the communication system. In the system itself, there is a type of noise, or there is a source of noise. So that is the fluctuation noise. So this is internal to the system. So this may be considered as external. This may be external to the system, and this fluctuation noise is internal to the system. That is, the source of the noise is in the system itself, or the system itself generates the noise. So here we have two different type of noise. One is the short noise, and another one is thermal noise. So these two are the internal to the system, and they are called as the fluctuation noise. So this short noise is due to, normally it occurs in the vacuum tubes, or the semiconductor devices. Semiconductor material. So normally we are using the semiconductor devices in almost all the circuits or all the systems. So if we take a communication system, we have an amplifier in it. So the amplifier itself uses the semiconductor device called the transistor. In the olden days we used the vacuum tubes. Nowadays they are replaced with the semiconductor devices. In the vacuum tubes, I think you might have heard, we have cathode, anode, and a grid. So due to the random generation of charge particles, here the charge particles are electrons, some current will be generated, or randomly generated electrons from the cathode constitute some amount of current. So that current is called as the short noise current, and that current waveform may look like this. Some random variation, because the electrons are generated randomly from the surface of the cathode. So these electrons that are generated from the surface of the cathode constitute some current. So that current waveform look like this, varies in a random fashion. So that current is called as the short noise current that occurs in the vacuum tubes. Similarly, in the semiconductors also, due to the diffusion of the charged particles, this short noise takes place. This type of noise called the thermal noise that occur in the conducting material like resistors or semiconductors. So this thermal noise is due to the Brownian movement. I think you might have heard about the Brownian motion because of this Brownian movement of the charged particles. That is, when the electrons or charged particles acquire thermal energy. So due to the acquired thermal energy, the charged particles wander randomly in the crystal lattice of the conducting medium. So here the motion of the charged particles is random and zigzag. So they move in a there is no particular fashion of movement. So they wander randomly in zigzag manner. So that's why that is, if you consider an electron, the electron that acquired some energy, initially it may be in this direction and it may collide with some other particle and its direction may be changed, and then it may collide with the crystal lattice or walls of the crystal, again the direction may be changed. So therefore the direction of these electrons is random and zigzag. So therefore the current constituted by these electrons or these charged particles which are moving with the acquired thermal energy constitute some current. So that current also in the same form, that vary randomly and in a zigzag manner. So definitely that type of current generated due to thermal agitation of the charged particles is called as the thermal noise current or the thermal noise. Here the source of the noise in both the cases is internal to the system. If you consider a semiconductor or if you consider a resistor, as we have the conducting medium, definitely we have the charged particles, and if the temperature, ambient temperature is changed, the electrons or the charged particles acquire the thermal energy and they wander randomly in the crystal lattice. So this random movement of charged particles constitute some current. So that current is called as the thermal noise current. But if you consider in both the cases, as an average, the amount of current is 0. Why? Because, see, if you consider this waveform, so the area under this may be equivalent to area under this and this. Similarly, area under this may be equivalent to this. So therefore, as an average, the number of electrons crossing from one side to another side in a conducting medium will be same. So therefore, the currents nullify, and as an average, the thermal noise current or the short noise current is 0. But still current is existing, but the average value of that current will be 0. Because all the electrons or charged particles wander randomly. That is, the number of electrons crossing a particular cross section area from one side to another side will be equivalent to the number of electrons that are crossing from this side to that side. So therefore, as an average, the current can be considered as 0, or the mean value of this particular thermal current or thermal noise current is 0. So that statement is also applicable to the short noise. Similarly, if you consider the semiconducting medium, we have the two different type of particles, electrons and holes. Due to the random recombination of these charged particles, some noise will be generated. So that noise is also called as the thermal noise. And similarly, the diffusion of the minority carriers. If the charged particles are recombining, definitely we observe some difference in the charge density. If there is a difference in charge density, definitely diffusion takes place. So due to the diffusion of the minority carriers in the semiconducting medium, the thermal noise current will be generated, because these charge particles, minority charge particles that are diffused from one material to another material in the semiconductor, or one side to another side, constitute some amount of current. So that current is the random current, and that is called as a thermal noise current. Okay, understood the difference between the short noise and the thermal noise. So the short noise is due to the random generation of charged particles or electrons from the cathode of the vacuum tube. This is due to the random motion of charged particles due to thermally acquired energy. That is the difference.